In this video, I'm going to be giving you a crash course on everything related to transitions and actions and forms inside of React, specifically in relation to 5 main hooks that deal with these things. We're going to be covering useTransition, useDeferred, useActionState, useFormStatus, and useOptimistic. And I'm even going to be diving into the detailed profiler dev tools to understand exactly how all these transitions and different background jobs work, so you can make sure you understand everything at a super low level to properly optimize all of your applications. Before we start diving into some of the hooks that I want to talk about, we first need to understand how transitions and some of this asynchronous stuff happens in React by comparing blocking versus non-blocking state changes. To do that, we have quite a bit of React code pre-set up, but I'm going to go through it real quick because this essentially is the framework we need to understand everything. First of all, we have 2 state variables. We have one for the currently selected tab that we're on. You can see these 4 buttons on the right hand of my screen correspond with each of those 4 different tabs. When I click on them, you can see it transitions between these tabs. I then have a count variable right here, which is just a counter up here that I can increment by clicking the plus button. And finally, I have a change tab function, which just calls set selected tab, so we can change what tab we're currently on. This little bit of code right here is just this counter. So when I click plus, it increments my counter. These buttons right here just change between which tab we're on. So if I click on 1, I move to tab number 1. And then you can see down here, I'm just rendering out the correct tab based on which button I click on. So tab 1 and tab 2 are super straightforward. They just render out the text 1 and 2. But we have a few more complicated tabs, which are the blocking tab and the asynchronous tab, which is pretty much where all of the important code that we're going to be talking about is happening. So if we go ahead and we look at the tabs here, this blocking tab, all it does is it creates an array of 10 different items based on that starting count that we give it. So it'll actually depend on this starting count. And then it just renders out each one of those items. And we're using essentially a little bit of a blocking piece of code right here. This code just waits for 50 milliseconds before it does anything. These red squigglies you can pretty much ignore. They're just React warnings telling me not to use performance.now in my component, but this is purely for demonstration purposes. I want to show you what this would look like if you had a slow component or something that took a long time to render. So each one of these children will take 50 milliseconds to render. Also, since we're in strict mode, that'll actually cause each of these components to render twice. So realistically, they will take 100 milliseconds each one. And since we're rendering 10, that means a 1 second delay every time we try to render our blocking tab. And if I click on this blocking tab, you'll notice it'll take 1 second after I click on it before the content shows up on our screen. And the most important thing is when I click on it, the rest of my application is entirely unresponsive. You notice when I was hovering over all these buttons, if I click on this blocking one, no highlighting happens and I can't interact with my state or do anything else. It blocks my entire app, which is hence the name blocking. Then if we move on to our asynchronous tab, this one is purely for testing out how this works with suspense. We're using React Query to use a suspense in this project, but it doesn't matter what you use to create a suspense boundary. Essentially, all this code does is every time that I change my count, it's going to go over to my async tab and it's going to load a fresh piece of data. So if I'm on this async page, you can see it says loading just like that. And if I change my count, it goes back to that loading text before it shows me the next piece of data. That's all that this code is supposed to be doing. So it's really just showing how suspense related stuff interacts with these transitions versus blocking state changes. Now that we understand all of the code, if we go back into our app, the first thing we want to tackle is this blocking tab right here, because when I click on this, essentially my entire app freezes for 1 second, which is a horrible user experience. To fix this, we can use a transition. Essentially, a transition in React is saying, hey, this thing that I want to change is less important than everything else, so it's going to happen in the background, and everything else is able to happen and work just the same. And then once everything is done rendering, it'll then push that information to the actual page to be shown up. So what we can do inside of our code is we can use a fancy hook called useTransition. This useTransition hook is going to return to us 2 values. We're going to have a pending property, which is just a Boolean telling me if it's currently loading or not. And then we're going to have a function, which is generally called something like start transition. So we're going to come in here with a start transition function, just like that. And this start transition function is just a function that you wrap other code inside of to tell React that all of this code is transition-based code. So what I can do is I can take my entire set state right here and I can wrap it in that start transition. And this takes in a function, and all it does is it runs the code inside this function immediately. But the key is that it queues up any state change to happen in the background. So whenever I change my selected tab, instead of that blocking my entire page from working, it'll push that off into the background, wait for it to finish, and then it'll give me all those changes at once. To show you what this looks like, I'll just come in here with a simple console.log. We're going to have this one say before. This one is going to say during to show that this happens during, and then we're going to have after just like that. Now, if I give that a quick save and I inspect my page and we go over to the console, and all we need to do is just change something on our tab. So let's say that we go to tab number 2, you can notice it says before, during, and after. So this is slightly different than like a normal state function. If you were to use set state or set selected tab as a function, that runs later. So this during code would run later. But this start transition code runs whatever is inside of it immediately. All it does is essentially delays this update from happening until later. And when we test this code and we click on blocking, you'll notice the rest of my application is still interactable while that other code is happening in the background. Now, technically speaking, there are still small delays. If we go back into our tabs here, you notice that each one of these delays for 50 milliseconds. So essentially during the time that it is rendering these 50 milliseconds, I am blocked on my page. But since it's breaking this up so that it's doing 50 milliseconds and then letting me do things on my page, then 50 milliseconds and letting me do something on my page, it realistically doesn't feel like there's a huge block happening in my code. Also, in a real world app situation, you probably don't have a single component that takes 50 milliseconds. You maybe have 1,000 components that each take 1 millisecond to render, so that perceived pause is really not there at all. And even when I'm interacting with this app, there's really not a huge amount of perceived delay in everything that's going on. But in a more real world scenario where you have a lot of smaller components, it's even less so of a problem. Because essentially what's happening is it's rendering each one of these components, and while that's happening in the background, it's letting everything else happen in the foreground. So it renders a component, and then it does stuff in the foreground. Then it renders a component and it does stuff in the foreground. Essentially, it only renders these components when it has a break in the time that stuff in the foreground is actually happening. We can actually really easily see this by diving into the performance tools built into the dev tools. So if we go and click on inspect here and we go over to this performance tab, this is going to give us a ton of information. But realistically, what I care about is I just want to click on this record button and I just want to click on this blocking tab, and then we'll click off immediately. Everything works fine. We'll click on it again and let it fully render, and then we'll just finish by clicking this pause button on this. Now, essentially what I want to do when I look into these dev tools, I know it's a little bit hard to see. Unfortunately, it's hard to make it too much larger. But essentially, if we scroll down, we have this scheduler section right here. And you'll notice there's a blocking section and there's a transition section. And essentially, whenever we offload certain code to happen in a transition layer by wrapping it in start transition, it's going to do that render down in this section right here. And you'll notice something that's really important about this is this one was interrupted because we clicked on it and then we clicked off. So you notice it was labeled as an interrupted render, while this one was a full render because it was able to finish rendering every single thing inside of our application. So this is really nice because we're able to offload that stuff to work at a later time in the background while everything in the foreground runs just fine. And then essentially if it finishes happening, you can see right here at the very, very end is essentially committing those changes. So that part where it's actually blocking is very small because that commit is only a few milliseconds of time. Now, if we were to remove that start transition, you'll notice an entirely different feel. So let's just come in here. We'll remove that start transition and all those logs because we don't need them anymore. There we go. And we'll do the exact same thing. I'm going to come over here, click record. I'm going to go from this page. I'm going to click on blocking and my entire app is completely frozen. And you'll notice that's because all of this rendering, this entire second render happens in this blocking category, which means nothing else can happen. So your entire application essentially freezes for the entire time it takes to render this component. Now going back into our code, another really nice thing, if we just bring that start transition back in, is we have this pending state, which easily lets us tell if something is loading or not. For example, I can just come into here and I can just throw in that pending state. And I can say, if we are in that pending state, I just want to render out the text loading just like that. And now when I go ahead and I try to render out something that is going to be loading in the background, when I click on this, you can see that loading text pops up. And as soon as my content is finished loading, it shows that content on my page just like this. Now I'm going to slightly change our code to really emphasize something related to suspense. I'm just going to take my suspense container and wrap my entire section of code inside of it. So now essentially our entire thing is wrapped inside this suspense. And if I were to go ahead and I go to number 1 and I go to my async, you can see now instead of getting that suspense to show up, it actually shows the loading state. You can see here I'm getting the full suspense because I'm re-rendering everything. But the very first time I go to this and I'm causing that transition through this start transition, you'll notice if I just refresh my page to get that to show up again, that it's showing that loading state right here instead of showing that suspense state. And that's because whenever you use a transition to change states, what's happening is React says, okay, you're using a transition. This is a background thing. So it doesn't actually show the fallback state of your suspense. It only shows the fallback state of a suspense when you're doing a full render that's not inside of a transition. So a traditional blocking render. Now, if I were to remove the start transition from this, so I'm no longer using transitions, refresh our page and click on async, you see we get the full suspense loading state every single time. But when I wrap it inside of a transition and I go back, you notice I just get the loading state directly in my transition, and it waits to change my code until after everything is finished loading. So it's important to understand the differences between these two, because sometimes you may want to show the suspense state and sometimes you may not want to show that state. So depending on your needs, you may want or not want this start transition just thrown in there. Now, while we're on the concept of these background transitions, I want to talk about another hook, useDeferredValue, that can essentially do the same exact thing as a transition, but it works in a slightly different way. So instead of using start transition here, we can actually completely remove that code and we'll go back to essentially the broken state where everything is being blocked. But what we can do instead is we can use a deferred value. So I can come in here and I can get a value which we're going to call deferred tab. I'm going to set that equal to using the useDeferredValue hook. And all you do that pass to this hook is you pass it the value that you want to defer to a transition-based update. So essentially now I have two different state variables. I have my selected tab, which updates immediately, and then I have my deferred tab, which updates in the background. So essentially what happens is anytime I set my selected tab, it's going to update this state variable immediately. Then what it's going to do is it's going to render a second time where this deferred tab is set to the correct value. So it renders once where this value is still the old value and this value has been updated to the new value. And then it renders a second time where this deferred tab value has been updated to the correct value. So essentially you get one immediate update for anything that can happen immediately with selected tab. And then you get a deferred update for anything that relies on this deferred tab. So for example, I can use my deferred tab all of these places down here, and it's essentially going to defer updating the tab content until later, but the actual tab itself can be rendered out properly. So I can come in here with a simple selected tab, and that'll render out what my currently selected tab is, and I can also render out what my deferred tab is, and we should be able to see both of these pieces of content on our screen. You can see right now, both of them are 1 and 1. Now let's come into here and close that off just like that. There we go. So now you can see my current tab is 1 and my deferred tab is 1. When I click on 2, you can see they both essentially update instantaneously because there is no big delay. But when I go to my blocking one, you can see here my selected tab is set to blocking, but the deferred one stayed as tab 2 until it finished doing the update. And the important thing about this is my entire app is still essentially as responsive as it was before. You can see here, everything is responsive. If I refresh, click on this, you can see it stays as async. And then it goes to async after a full second or whatever to finish rendering out this data. So we can get the exact same behavior between transitions and this deferred state, and we can even get a loading state. For example, I can say const loading, and all I can do is say if my selected tab is not equal to my deferred tab, well then I'm in the loading state because essentially these two things are different, which means we're loading that transition in the background. So the question pretty much comes down to when would you want to use one over the other? I would say for most use cases, you want to use the useTransition hook if you have access to the ability where you set the actual state. So if you have access to the code that is setting the state, or a function that's setting state, or anything at all that's modifying the state directly, useTransition is going to be better because it's much easier to use. It has the pending state built in. All you have to do is wrap it in a start transition and everything works fine. You don't have to worry about changing this selected tab and this deferred tab because now I have two different variables that I need to keep track of. But if I'm in a scenario where I don't have access to this state setter, then you can use this deferred version to essentially do the exact same thing, but without having to wrap everything in start transition because you don't have access to the function that's actually setting the state. Because if I don't have access to set selected tab, I can't wrap it in a start transition, which means I can't use this useTransition hook. So that's when you want to use useDeferredValue. Another instance where useDeferredValue is really useful is when you want to show essentially the old value and the new value at the same time. A really common instance of this is if you're typing in an input, for example, or changing some type of state on your screen where you want instantaneous updates as the user's typing, but you want to delay the update for the thing that is much slower. This count variable is actually a really great point for this. So I'm going to come in here, I'm going to rewrap this inside of our start transition because we can leave that as it was before. So anytime we change around our tab, it's going to be using start transition and we'll update all this code back to essentially the way that we had it before. So there we go. Now you can see that all my stuff is working just like it was before for changing around all of my different tabs. Now the big difference though is that if I come into blocking here and I increment my count, you're going to notice my app immediately freezes because this count update is not wrapped in any type of transition stuff at all. So we have a problem with this count section right here where we're getting freezes inside of our app. So what we can do instead is we can essentially get a deferred count. So I can say deferred count, and of course I don't need to wrap that like that. And that is just going to be equal to the use deferred value hook. I'm going to pass in my count here. And now what I can do is I can use my correct count right here to display what that's going to be. But I can pass my deferred count down to these functions where I want to only use the deferred value because those things can happen at a later time. So now if I do that, I can go to my blocking page and everything loads just like it did before. I can increment my count up here. You can see I get no issues. And then in the background, it's rendering out what the new version of that should be. So essentially when you want to be able to update a piece of state and make that instantaneous while leaving another piece of state that relies on the same data to be delayed, that's an instance where use deferred value is really useful. I find that I use this most often with like inputs for search boxes that are going to be filtering data that's maybe slow or takes a significant amount of time. Otherwise, I only use it when I don't have access to that state setter function because usually I can just wrap it in a start transition, which is much easier to work with and deal with. Now I've gone ahead and drastically changed our code over to a form, and that's because I want to talk about actions. And this is something we've already actually seen, and that's because every time you use start transition, the code that you pass to that function is technically called an action inside of React. And these actions are essentially things that happen in this transition period for us. And what I want to show you is how you can use actions with forms because there's a special hook specifically for that. So this is the traditional way you would use a form inside of React before using this action-based way. You can see we're keeping track of a loading state. We're keeping track of the response we get back from saving this form. Usually it's like an API call or something like that. And we're also keeping track of all of our different input refs and different things inside of our form. Now, if we look at our form before we handle the onSubmit function, you can see we just have a form that's handling that submit. We have a label for our name. Our input is just hooked up to that input ref. And then we have a button that's disabled when we're loading. And you can see if I type something in, click save, you can see it's disabled. And then it shows me whatever that response is down below here from our API call. Now, if you check inside of here, we're just making sure we prevent the default. We're making sure we set our loading state while we're waiting for our content and unsetting it when we're done with our content. We have some really simple validation inside of here based on our API. We have a fake wait time, essentially to simulate calling out to an API on the network. And then we're just setting a response that includes whatever our value is and the code success. So at least we know this was a successful response. Now, unfortunately, this is a lot of boilerplate code just to do a really simple form. And as your forms get more and more complex, you have more and more boilerplate code that you need to write. This is where the useActionState hook comes in. So we can come in here, useActionState just like this. And this useActionState is essentially going to handle everything related to this code for us. So we can come in here, we can get some information from this. It's going to return to us quite a few different things. So if we look inside here, the very first thing that we're going to get returned is going to be whatever our response data is. So we can just get our response just like that. That's going to be essentially taking care of that state variable for us. The next thing this is going to return is an action. This is the thing that essentially replaces our entire handle submit for us. This is what we use as the function we call to update our data. And then finally, the last thing that's going to be returned from this is going to be an is pending, or in our case, we called it is loading state. So that takes care of this entire state variable for us. So now we've essentially removed all of our state and put it directly in this useActionState hook instead. Now this useActionState hook is going to take in two properties in particular. The very first property that we're going to be passing to this useActionState hook, if we take a look, is going to be the action, essentially the function that we want to perform. So we have some type of function, and this function is essentially going to take all of the code inside of our network request or API call, whatever that is. We're just going to paste that directly into here. So this is our validation and then calling out to our API. Let's make sure that this is asynchronous so we can handle everything inside of here. And instead of setting some type of state variable, all we need to do is just return whatever we want our response to be. So in our case, we're just returning that success response back to the user for us. We should also probably return some type of error response. So I'll just say error if the validation was incorrect. So now we're getting a string return that's either success or error based on the content that we're passing in. Now we also need to pass along a second parameter to this, and this is going to be the initial state we default this to. For now, I'm just going to set this to the text of initial just so we can see what's going on inside of our code. And the thing that you'll notice is we are still using this input ref up here, but we can actually get rid of that completely. So I'm going to get rid of the input ref here, get rid of this entire handle submit, get rid of this on submit here, and this input ref right here. And that's because in the form, we can pass along an action, and we'll pass along our action right here. And if you use an action inside of a form like this, it's going to pass along our form data, as you can see here, to our action. So here we're going to have access to our form data, which is of that form data type. But we're technically going to get two things passed to this function. The first is going to be the previous response data, and the second is going to be the form data. So we can call this previous response just like that. And in our case, this is a string. There we go. So now if we take a look at the code, we have this previous response and we have our form data, and we can use our form data to get our input. So we can just say name is equal to form data.get, and and we can get the name. And that's because we called it name right here. So the name of our input is name. That's how we get that data up here. So now I could just replace all of this input stuff with our name specifically. There we go. And that cleaned up all of our different code. And before we start diving into the minutia of how this actually works, I want to show you everything over on the side to show you the demonstration that these two pieces of code are exactly the same. So if we refresh our page, by default, this initial value is shown as our response. If we type something in as our name and we click save, after it finishes loading, we get that success with that response being returned. And if we had an empty state, you can see we get the error being returned. So everything is being handled properly inside of our code. Now you're probably having a lot of questions about what is this previous response? How do we get this form data and everything like that? And the reason we're getting the form data, first of all, is because we're using this action on the action prop specifically on a form. This just automatically passes along your form data for you. Now, if you didn't want this, you could still use the onSubmit and you could pass it your own function. So for example, we could pass it a function that's going to call our action and do something with it. And we could pass along like a string or whatever if we wanted to, but then we are manually passing that along. We also need to manually make sure we prevent our event and so on. So when I'm working with a form, I pretty much always use the action directly like this and just get my data from the form directly like this. And that works really well. Also, you'll notice this previous response being passed along. Essentially, inside of every action that uses this useActionState hook, it's always going to pass along whatever the previous response was inside of this content. So we can just do a quick console log of that previous response so we can see what this looks like. If we inspect our page, we go over to our console, clear everything out, and if I just refresh my page, here we go. We can type some content in, we click save. You'll notice initial is the first value returned because that's what the previous value of our response was. If we type in some new data, we'll just type this in as second and I click save. You'll notice we get essentially what the previous response was. So every time this function gets called, it not only passes the current form data, but also whatever the previous thing we returned from this function was. For the most part though, I don't actually use this, so I just prefix it with an underscore because it's not a variable that I care about. You'll also notice something interesting about our form. When we actually submit our data and click save, it actually clears out all the content in our form. This is the default behavior for how this hook works when you have it hooked up with a form like this. Depending on what you want, you may want or not want this behavior, but if you don't want this behavior, the nice thing is you can very easily get around that. For example, I could just say here that my data is going to be equal to this whatever return value that I get is, and then I'm also going to have essentially my form fields. In our case, we only have one form field called name, so we can pass along our name like that. So essentially I want to do the exact same thing here. This one's just going to say error like that and pass along our name. And then finally for our initial value here, the data is going to be initial and our name is just going to be an empty string, just like that. So now we have essentially all the placeholder content for all of our data. And to fix our error, we just need to make sure that this type here lines up with everything. So our data is a string and our name is a string, just like that. And we are still getting a little bit of an error. And I believe that's because of this TypeScript. This essentially could be null. So I probably just want to make sure to check that it is null. So we can come in here and we can say that our name is going to be equal to an empty string if it's null. And here I'm just going to call toString, and actually that should clean up the code directly for us. There we go. So now we have all that set up and we're passing along that name property. So in our response, we have our data and our name. So down here, I get my response.data, and now everything will work exactly as it did before. As you can see here, if I refresh, we get that initial value. And when I type something in, it shows up. But to make sure our name stays the same, we can just come in here, set our default value to our response.name, and that'll just make sure our value for this is properly set. So when I try to type something in, click save, you'll notice that that value stays the same and it doesn't reset itself. Now that's pretty much everything there is to this useActionState hook. The most common play that you're going to use this is with a form, as I've showed you here, but you can use this hook with literally anything that you want to use as an action. It doesn't matter. So you can use it with anything, which is really nice. Now, something that specifically relates to forms, again, is another hook, which is going to be about getting the status of everything related to your form. So let's just say that I had a random component. It doesn't matter what it is, but it's inside my form. That's the only thing I care about. We're inside of our form. And inside this child component, I want to access data about the status of my form. Luckily, there is a useFormStatus hook that we can use specifically for that. This useFormStatus hook doesn't take any props at all, but it is going to return to us a bunch of information. And it returns to us as an object. You can see we have the action, we have the data, we have the method, and we have the pending status of this. And by far the most common thing you're going to use from here is the pending status. So I can just come in here and I can return, for example, an H1, and we can say that it's going to return some pending data for us. So we can just say pending or finished, whatever, it doesn't matter. So you can see it's printing out finished because there's nothing currently pending. If I click save, it changes to pending because now our form is currently loading its data inside of it. So this pending status essentially maps one-to-one to this loading status returned from the action state. All of that is hooked up properly with each other. And we can come inside of here and we can get other information. For example, we can get our action. This is the exact function we pass into our form action property. So that gives us more information about our form. We can also get the data. This is essentially all of our form data. You can see if I hover the type of this, it is our form data, and it's only populated while our form is actually submitting. So while our form is in the process of submitting, it's going to be passed in whatever data is currently being submitted. So while my form is being submitted, I can see what data is being submitted specifically to my form. And then finally, I have this method property. This is just whether or not I'm doing a get or a post request. So you can see here, this is just a string. For example, if I change my method here, that just maps one-to-one between those two. But again, like I said, 99% of the time when I'm using this, it's so that I can get the pending status of my actual form without having to pass it down as a child prop. It just makes it a really easy way to get that information. And occasionally you actually want to get the data and do something with it. And this is, again, an easy way to do that without having to pass it around because you actually don't have access to this property anywhere except for inside of this function right here. So this is a great way to get that data and render it however you need. Now I've drastically changed our code again because I want to talk about the final form and async related thing, and that is optimistic updates, which are one of the most important things you can add to your application to make it seem faster, and luckily there's a hook to make it quite easy. In this simple example, I have a like button. When I click on this like button and the thing is currently liked, it'll say liked and the background color changes to red. But there's a big catch in that adding this liked status has to call out to an API to render and make sure everything's properly correct, and that takes 1 full second before the data gets back to me. So when I click on this button right now, you notice there's a 1 second delay before it actually turns red and shows me that I've liked it. And if I click on it again, there's a full 1 second delay. And if you're a user of this application, you may click on this multiple times because it's taken a while, and you'll notice it then quickly flops between different statuses because it's queuing up all these different things to happen one after another. This is where optimistic updates can come in, and luckily there's a hook, useOptimistic, that makes this incredibly easy. This useOptimistic hook takes in a value which is going to be the thing that you want to optimistically update. In our case, that's our like status, so we're going to paste that down right here. And then what we're going to do is we're going to get an optimistic version. So we can say optimistic liked, just like that. And this is going to work just like useState. So it's going to return to us both a set function, so we can say set optimistic liked, just like that. So now we have the version here that we can get the state from, and then we have the ability to set that state right here. And the key is anytime that you update your state, for example, here we're updating our liked status, before we do the thing that takes a long time, which is right here, that network request, we want to set the optimistic version first. So what I can do is I can come in here and say that I just want to toggle that status, just like that. So now I'm toggling between the two different states. And if I use this optimistic liked instead of my liked status down here, it's going to immediately give me optimistic updates. When I click on this, you can see it immediately changes state, but there's still a little bit of a problem with it. The reason it seemed like it worked for a split second, but really didn't overall, is because to make optimistic updates work properly, they must be inside of an action or a transition, since essentially a transition is just an action. So we can actually wrap them in a transition. So what we can do inside of here is we can say is pending, or there we go, is pending start transition. And we get that from that useTransition hook. And now I can just wrap this entire thing directly inside that transition. There we go. And that should make our code work. We just want to make sure that this is asynchronous here, get rid of that. And now if we give this a save and I click, you notice immediately it changes to that red state, and it stays that way when my thing finishes updating. And we can even show this pending status if we wanted to. So we can come in here and we can say that if we're pending, we just render out some text onto the end here. So we'll say if it's pending, then we just say pending. There we go. Just so we can see that pending status. So you can see it's pending, pending, pending. And then as soon as it's done pending, it stays as that current state. So this optimistically updates us to the new state. And then as soon as it's done doing that optimistic update, it makes both of these values exactly the same. Essentially, the way that this works is whenever this value finishes updating, it then replaces this value with the value that we finished updating. And this is important because sometimes your update may fail. So to emulate what a failure would look like, we're essentially just not going to update our set liked because it's not going to be changing at all because we had a failure that meant when we tried to like it, it did not work properly. So when I click this, you can see it changes to red and it's pending. And as soon as the pending status is done, this transition is finished, it now says, okay, I'm done. let me update this optimistic version with the actual correct version. And it says, oh, these are actually different because the value never updated like we expected it to. So it properly updates my UI to show the correct version of my application. So it shows them the pending status, the optimistic version, and if there is a failure or it's different than our optimistic expectation, it'll show us that correct version. So this use optimistic hook is a really useful one for whenever you want to do optimistic updates anywhere in your UI. All you need to make sure is that you have these things wrapped inside of some form of action, whether it's a form action, a start transition, or something like that. And then we want to make sure that you properly update the state for the optimistic and the normal version inside of that action. Now you can also take this a little bit further, and you can use this use optimistic hook by passing along a second property. And this actually works very similar to like a reducer, because essentially what it's going to do is it's going to take in our current state and it's going to take in some type of action. Now this action could be literally anything. You could go full like reducer and make it an action with like a type and a payload, or you can just pass along like some value. It really doesn't matter what this particular thing is, but now I can use this to return a new version of this state for me. So I could just return value as my new thing, or I could do like state and value or something like that to combine these different things together to make them work properly. But it's just another way that you could use this. And then essentially this set optimistic liked is going to call whatever this second parameter is by passing in your state and then whatever this value is. So if I said that this is a value with a string, or let's make it a Boolean, there we go. Now you can see it's returning me a new Boolean, and this set optimistic like takes in the Boolean as the action. So this is a way for me to create like a more reducer version of this. It doesn't really make a lot of sense for a simple variable that's a Boolean like this, but if you're dealing with like arrays or objects where you're changing small things on them, it may make more sense to use this second version. But I find myself 99.9% of the time when I'm using this hook, I just use the standard version because it works just like the useState hook. So it's really easy for me to conceptually handle and work with in my application.